Hey there, welcome back. It's that math guy again. Just jumping into my third video here. Hopefully the vocab examples were helpful to you. Today should be a pretty quick video, just going over the number systems, just classifications of numbers basically. As always, my YouTube and email are up at the top, so let's go ahead and jump right in. First of all, just, numbers are not just numbers. They're all broken into categories. Some you may not have even heard about yet, which, again, we'll get into more of the nitty gritty down the road. But what I have here is kind of a spectrum of, of these classifications. Each layer above includes all of the examples down below, so you'll see what I'm talking about in a second. But we're just going to start right down at the bottom. So the lowest rung here are what's called the natural numbers. In other words, these are your counting numbers. So it's all the whole numbers, 1, 2, 3, 4, on and on and on and on. Just the counting numbers, the natural numbers. That's the first category there. The next step up is going to be our whole numbers. So this includes all of the natural numbers plus 0. So 0, 1, 2, 3, 4, on and on and on. Okay, I come up with silly ways to remember things all the time, so I just remember, oh, there's an O in whole, so I add the 0. I don't know. It works for me. Maybe it doesn't work for you, but just to show you the way my brain works. So those are your natural numbers, your whole numbers. Moving right along, the next step up, next classification, integers. Okay, so those are going to include all of the whole numbers and then the negative values of those as well. So, all of those negative whole numbers, -3, -2, -1, 0, and then all of those whole and natural numbers onwards, both sides of 0 in this case. Again, still no fractions or remainders or anything like that, or decimals. So far, everything is just a nice round number. Moving on. Okay, this is where the definitions start to get a little bit tricky here. Are your rational numbers. Okay, so again, this includes all of the numbers down below, all the integers, all the whole numbers, all the natural numbers. But rational numbers are essentially any number that can be expressed as a ratio or a fraction, or they terminate or repeat if they're a decimal. I'll show you what I'm talking about. So all the numbers below, these are just additional examples. So rational numbers, 1/2, it's a ratio, it's a fraction. Okay, it can be expressed as a fraction. 3.2, it's a decimal number. When it comes to the decimals, like I said just a moment ago, they must repeat or they must terminate. In other words, it means they end. So if they go on forever, they must repeat in a pattern. So for example, if I said 1.612612 and it kept repeating, that's a rational number because it's going to have that same exact repeating pattern even though it never ends. Or again, it's a terminating decimal just like 3.2. It could have several decimal places and just end after 3 or 4 or 5. But as long as it ends or repeats, terminates or repeats. And again, if you see something like this, 4.7 with a bar over the top, it means that 7 is going to repeat itself. And that could be said sort of as the 1.612. It could have also been written as 1.612 with a bar over the top. You just know 612 is going to repeat. So if you ever see a bar over the top of a number like that, you know it repeats. So those are all examples of rational numbers. Okay. Now, oops, OneNote's acting up on me. So the next layer up here, if this will let me move, I swear, technology never wants to work when I want it to work. Thought it was going to be a quick example. All right. So the rational number system is everything like we just gave you, and then below all the whole numbers as well. Now we're going to get into the rest of the real numbers. So it's all the numbers below, all the rational numbers, all the integers, everything like that, everything below it. So the new addition here to the real numbers is going to be the irrational numbers. So if rational means that they can be expressed as a fraction, or the decimals will terminate or repeat, irrational numbers are never going to terminate or repeat. Or they, in other words, cannot be expressed as a fraction because they don't terminate, they don't repeat. There's no way to condense it down to a fraction. So a couple of examples of irrational numbers. I'm just making this up here off the top of my head. 1.6127834094778. There's no discernible pattern to that, and it just keeps on going. That's an irrational number. A lot of times when you divide numbers on your calculator, you get a decimal, it just keeps on going. It's going to be irrational. So that's what one example. Another really good example, some of you guys might have already been thinking about this. I'll give you a couple seconds to see if you are thinking about what I'm thinking about here. A very common one. It's not necessarily always written as a number, but pi. Pi never ends. I guess you could argue it's a ratio, but it's not. You're not able to express it as a fraction. It's the ratio of a circle's circumference to its diameter. 3.1415, and it goes on forever and ever and ever, doesn't ever repeat. So those are irrational numbers. Those are some examples of irrational numbers. You may also come to deal with E a little bit later. We're not going to get into that. But those are all irrational numbers. Again, that's a number that does not terminate, does not repeat. 2.73, blah, 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 blah. Or 2.72, just rounds up to 2.73. Moving on here, I'm not going to spend a ton of time on the last couple of rungs on this ladder here, but we're going to jump in to a realm here that you may not have heard about. Okay, we've got all of the real numbers. So if we're going to expand even further, we've got to think outside the realm of real. So the next step, the next set of numbers, if this stupid box will move out of my way, if there's no more real numbers, we got to start dipping into the imaginary numbers. Now, that doesn't mean I just make up numbers or, I'm just inventing my own language. It just means that these are numbers that don't have real value. I'm not going to get too far into that, but imaginary numbers, in other words, I swear, imaginary numbers are going to be written, well, they're going to be written as soon as this technology allows me to. They're going to be denoted by, oh my goodness, by a lowercase I. And the value of I is the square root of -1. If you know anything about square roots, you're going, wait a minute. That means it's a number that multiplies by itself to give me -1. Well, if you know anything about the multiplication rules, a negative times a negative equals a positive, and so does a positive times a positive. So there's no way. We'll get more into that when we talk about solving quadratics, solving polynomials, but just go with it for right now. So it's any value that has this I in it or has the square root of a negative number, which again is impossible. So anything that has an I, 2i, anything like that, those are all imaginary numbers. Square root of a negative, anything in that realm. Okay, and then the last step here is going to be our complex numbers, and that's just a combination of real and imaginary. That's all it is. So it's something like 7 plus 2i. We have the real, we have the imaginary. Okay, and when we do complex numbers, I know it kind of looks backwards because, the letters at the end. Usually we say 3x plus 7. Well, those are all real numbers that we're dealing with there generally. This time we go real then imaginary. So -3 plus 4i. 5 minus I. Those are all complex numbers. We'll deal with those a lot more later, but just wanted to kind of dip our toe in right there. So if we take a step back, one last look at all the steps, okay? All the different classifications, natural numbers, counting numbers, 1, 2, 3, 4, on and on and on. The whole numbers, 0, 1, 2, 3, 4, on and on and on. The integers, all those negative numbers, again, hitting the whole numbers, basically your number line numbers, -3, -2, -1, 0, 1, 2, 3. And then the more complicated ones, rational, real, imaginary, complex. So those are pretty much all the numbers we're going to kind of be dealing with here. Again, great to know definitions. You got to know what words mean when it comes to math because it's very, very precise. Let me know if you have any kind of questions. Feel free to shoot me an email if something wasn't making sense or you have a question, or again, have a suggestion of a video that you would like to eventually see. Looking forward to hearing from you guys, and hopefully that helped.